All right, so we're going to keep talking about statistics, but this lesson is on population mean and population proportion. And some of these words we talked about yesterday too. So a population is any large collection of objects or individuals, such as Americans or students or trees, about which information is desired. And this next word is a word you may have never heard of before, but a parameter is any summary number like average or percentage that describes the entire population. Right? So if we wanted to find the mean of the entire population of something, it's represented by this Greek letter right here that is called mu. It's not a very common Greek letter, but it means the population mean or the population average. Right, and then if we wanted to find a population proportion, that's represented by P. And those are two different parameters. So for example, you might be interested in finding the average weight of all middle-aged female Americans. The population in that case would be all middle-aged female Americans, and the parameter would be mu, the average of the weight. Or you might be interested in learning about the proportion of likely American voters approving the president's job performance. So the population would be all those voters, and then the parameter would be P, the population proportion. Now, the problem is that there are about 40 million middle aged women in the United States. If you are actually going to find mu, the population mean, you would have to find out the weight of 40 million people and find the average of it. And then there are about 168 million registered voters in the United States. So if you actually wanted to find the population proportion, you would have to get information from that many people. And so it says that 99.9999% of the time we can't do that. So instead, we use a sample. And so a sample, and we talked about that yesterday, is representative of the group drawn from the population. And then if you get things like average or proportion from a sample, it's called a statistic. So if you get the average or proportion from the whole population, it's a parameter. They start with the same letter. That's how I had to take a couple of statistics classes in college, and that's how I remembered. The parameter goes with population because they start with the same letter. A statistic goes with the sample because they start with the same letter. So we can find a sample mean. Now, a sample mean is represented with this symbol here that's called X bar. Or we can find a sample proportion, which is called P hat. It's kind of goofy sounding, but that's what it's called. So instead of trying to speak to 40 million people about how much they weigh, you can just find a random sample of 100 middle-aged people, get the sample mean, and use it to estimate the population mean. Right. Same thing for the job performance with the voters. You can just take a random sample, figure out their proportion, and use it to estimate the proportion of the whole population. So that's what you do with statistics. You just use a little bit of the population to estimate for the whole. All right, so let's look at example 1. A radio station surveyed a sample of listeners to find their favorite music genre and found the following results. What is the estimated population proportion of the most preferred music genre? So what is the most preferred music? I can't say the words. Rock. And there are 52 people who picked rock out of the sample. And then to figure out what goes in the denominator, it should be the total number of people that they surveyed. So you would just add up this column right here, and that should be 158. Now, I know when we were doing probability, that's how we pretty much left our answers as fractions, but with statistics, a lot of the times is written as decimals or percentages. So any kind of calculator you can take and divide 52 by 158 and you get approximately 0.33, or what would that be as a percent? Do you guys know? 0.33 as a percent? 33%. So it could go either way. When you're changing decimals to percentages, you just move that decimal point over 2 places. Okay, so we did a sample proportion to estimate a population proportion, and that's pretty much what you have to do. All right, so let's look at the next one. So we have a sample of 10th grade honors Algebra 2 students were surveyed to determine the number of hours they spent studying or doing their homework each week. The results are shown. What is the estimated population mean? So remember, anytime you see the word mean in statistics, it means average. And so we have a sample. So we're going to estimate the population mean by finding the mean of the sample. So we're just going to add these numbers together and divide by how many numbers there are, which is going to be 7. And so any type of calculator can do this. So we'll just add. Okay, so I added, I got 45, and when I divide 45 by 7, I'm going to get approximately 6.43 hours a week. Okay, so the last thing we're going to talk about is margin of error. So a margin of error is loosely defined as the largest expected size of the difference between an estimate and the actual population value that is being estimated. So when we're estimating these population means and population proportions, we don't really know for sure if that's going to be the population mean, but the margin of error tells you it's going to be about this much in between. So let me show you what I'm talking about. So for example, if you were trying to estimate the average weight of a population based on a proper sample, your margin of error was stated as 2 pounds. That is saying that you would be confident that the actual population weight is within 2 pounds of your estimate. Right? And another example, if you obtained a sample average weight of 45 pounds and your margin of error was 2 pounds, then you would be confident that the actual weight would be somewhere between. We would take that 45 and subtract 2, so it would be 43 pounds. And we would take that 45 and we would add 2, and it would be 47 pounds. So the mean, and add and subtract the margin of error. All right, any questions on that? Okay, so we're going to do an example where we're going to find a mean and then we're going to find that confidence interval. Bless you. All right, so researchers have questioned whether the traditional value of 98.6 degrees Fahrenheit is correct for a typical body temperature of healthy adults. Suppose you plan to estimate mean body temperature by recording the temperatures of people in a random sample of 10 healthy adults and calculating the sample mean. All right, so here are our 10 healthy adults and their um, body temperature, and we're just going to add them all together. And that's 10 of them, and then we're going to divide by 10. That's going to give us the mean temperature for this sample. Okay, so I added them all together, and I got 987.57, and then I'm going to divide that by 10. I've gotten different things every time. So the correct answer, I must have just messed up on a keystroke somewhere. The correct one should be 98.78. Okay, so that's just finding the average of the sample, and then that's going to be estimated population mean. Right, and then B says that given the margin of error of this survey is 0.38 degrees, what can you confidently say about the population mean? So we would say that it falls between and then we'll take that mean that we got, 98.78 degrees, and subtract 0.38 from it. And it's going to give us 98.4 degrees. And we would take that mean and we would add the margin of error to it, and that would be 99.16 degrees Fahrenheit. All right, so again, this is a lot of words, a little bit of calculations today, finding the mean, proportions, and then the intervals that you're confident. What questions do you all have?